cutoff.
Ship SM's entered payload deploy prep.
Open the pod bay doors, Hal.
Ship's at payload deploy.
There goes another one.
Relight demo startup.
Starship is something.
Starship landing burn startup.
Minus 5 minutes and counting. Expected propellant closeout on both vehicles and expecting no issues going into today's launch attempt. 5.
Hello, everyone, and welcome to Starbase, Texas for the 11th flight test of the world's largest and most powerful and what's expected to be the final launch of our second-generation vehicle. I'm Amanda Lee, a build reliability engineer here at SpaceX.
And I'm Jake Berkowitz, a lead propulsion engineer on our SpaceX Raptor team. Today we're coming to you live from Star Factory, just under 2 miles away from the rocket on the pad. Right outside on the lawn, the crowd is starting to gather, and after liftoff, we expect that crowd to head back in to watch the rest of the launch with us and have a party.
And right behind us are 3 generations of Raptor engines, the third of which we're looking to debut on the next generation of Starship. And we'll talk a little bit more about that upgraded rocket later in the program.
Yeah, and if you watched Flight 10, you'll know it was a really, really good day for Starship. All objectives were met, and we got tons of great data to learn from. And today, we're looking to build on the success of that flight.
Yeah, that's right. Like in Flight 10, we're again planning to deploy Starlink simulator satellites as well as test the limits of ship's heat shield during re-entry. A controlled descent, flip maneuver, and soft splash in the Indian Ocean are also planned for ship. And hopefully, our recovery team will be able to deliver some more of those amazing views that we got back on Flight 10.
Yeah, those views are just awesome. Another crazy thing, and for those of you keeping track, today actually marks the 1-year anniversary of our historic first ever booster catch. That was Booster 12. And even though we're not attempting a catch today, every time we launch a Starship, it's a big day. All right, so everyone, buckle up because maximum excitement is guaranteed.
All right.
And Dan Hewitt joins us from over near Mission Control. Dan, how are things looking for launch today?
Hey, Jake. Hey, Amanda. Hey, everybody. We are looking great. I'm Dan Hewitt with SpaceX Communications. That's right. Right behind me is our Launch Control Center here at Starbase. Flight control team is on there. They're getting Starship and Super Heavy ready for liftoff. So as you can tell, when we look at the vehicle, prop load is underway. Things are looking good. We did shift our T0 a little bit. We're tracking to 6:23 p.m. Central Time, just a couple minutes into our window. All right, so as we noted, back in August, Flight 10, it did all the things. Did all the things we wanted it to do. Started off with Super Heavy, those 33 Raptor engines igniting, lifting off right at the top of its window at 6:30 p.m. Central Time. It was able to do a successful ascent, followed that up with hot staging, Starship's upper stage igniting those 6 Raptor engines, separating Super Heavy, making its way back down. We saw the hot stage pop off. It then completed its boost back burn, put it on the course towards that splashdown zone. It successfully did that landing burn when we intentionally disabled one of those 3 center engines. During the final phase of that, used a backup engine, entered into its final hover, shut down and splashed down into the water. Ship, meanwhile, completed full duration ascent burn, got to its planned velocity, successfully put it on that suborbital trajectory, and then it was on to the in-space stuff. That first in-space objective was completed. 8 of those Starlink simulators were deployed. That was the first successful payload demonstration we've ever had from Starship. Each of these simulators, similar in size to the V3 Starlinks that we're going to be launching next year to add significant capacity and capability to the network. Then it was on to our second ever in-space relight of a Raptor engine. That's a key capability for when we're going to do deorbit burns on future orbital missions, and then when we're doing deep space maneuvers. Then on to the critical reentry phase, we're able to get data on the performance of that heat shield, the ship structure, push the envelope on it, using the flaps, got it down to the splashdown zone, did the landing flip, did the landing burn. Killer views from the recovery team, soft splashdown over in the Indian Ocean. We were just about 3 meters off of our target, so pretty much nailed it. It was a huge day, tons of excitement here at Starbase. Just a reminder, though, this is still the early days. I mean, we're on Flight 11 today. There's a lot more we're going to do to get full reusability, increase our launch cadence, eventually start sending missions to the Moon and Mars. I mean, we've got thousands of launches to come. But for now, we're looking good for launch. Toss it back down to Amanda and Jake.
Awesome. Thank you, Dan. Starship is the first orbital launch vehicle engineered to be fully reusable, just like a commercial airliner. In fact, to the end, we're actually reflying a Super Heavy booster for the 2nd time today. This booster last flew on Flight 8. So let's just start with how powerful this rocket really is. When you stack Starship up against one of the world's biggest airplanes, the 747, a single Raptor engine is actually double the thrust of all 4 airplane engines put together. So that means the Super Heavy over on the pad right now, with its 33 Raptors, is equal to the power of about 64 747s.
Yeah, that's just crazy, Amanda. The power this rocket generates is incredible. To be specific, it's over 16.7 million pounds of thrust. Numbers almost incomprehensible, but it's just crazy. All right, to break it down, Starship is made of 2 parts. First is the engines. 3 are optimized for sea level performance, and 3 are for vacuum performance with that larger nozzle extension. All right, it's the Starship's second stage that will one day carry cargo, payloads, and people all the way to Mars and beyond.
The Super Heavy booster is designed to launch, separate, flip, and return to the launch site where it can be caught by the chopsticks on the launch tower. However, as previously noted, we won't be attempting one of those catches today. Starship, on the other hand, re-enters the Earth's atmosphere at the conclusion of its mission, steering itself to a vertical landing or catch. And both stages are designed to return to Earth and fly again, making this the first rocket in history that will be fully reusable.
Yeah, and we cannot forget that between the 2 vehicles is the hot stage ring, a structure made of steel that allows the ship's engines to ignite while still attached to the booster, enabling a faster and more efficient stage separation. Right now, that hot stage ring is single use, but in the future, it will be built in directly to the V3 booster forward end.
And finally, the infrastructure built to support Starship is referred to as Stage 0. This includes the launch pads, tank farm, and the launch towers, which hold the chopsticks that catch the Super Heavy booster and eventually will also catch the ship.
Yeah, and to get us ready for launch today, we recently conducted another static test fire, basically where we fire up the engines to mimic a launch without actually launching. You're seeing the booster on the screen right now. It's a crucial milestone to let us know we're ready to go. And then here we're seeing ship. We did this for the second time on a retrofitted mount on pad 1. We had a full 9-second duration burn on all 6 engines.
We should also note that today's launch on pad 1 is intended to be the last launch on this pad in this configuration. As we head into the next generation Starship flight test program, we'll be modifying pad 1 to meet the demands of our future missions.
Yeah, and among many other things, we're installing a new orbital launch mount, a new flame trench system, and upgrading the chopsticks for future catches. So until that's complete, we'll be running operations from pad 2, which will be coming online very soon. All right, let's go over to Hawthorne, where Tyler is ready to talk a little Starlink.
Thank you, Jake and Amanda. My name is Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Starlink is SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. So Starship is outfitted again today with 4 Starlink terminals, powering those incredible live shots of ship in orbit, through re-entry, and then all the way down to splashdown in the Indian Ocean. Now, we've had a couple of recent milestones that are worth celebrating. Back in September, we launched Starlink for its 300th time. And this summer, we surpassed 7 million active customers with service available across 150 countries and territories. We've come a really long way since turning on service for our first paying customer in rural Idaho 5 years ago, back in October of 2020.
Maples are looking beautiful.
I'm Wendy Layer. I live in Sandpoint, Idaho, and we are the first Starlink customers.
With Starlink, we didn't have to compromise on where we live due to the lack of technology.
The minute they turned it on, we could stream a movie, we could video chat, we could have the ability to work remote.
Here's my house. The program runs on the cloud. I can send anything I want out to get prices and designs.
I like to bake, so I've been able to research recipes and try new things.
Good day, go for a walk.
Good day for a walk.
We can live very rural, and yet we are connected to anybody like in the city.
And I'm happy to report that Wendy and Sean are still Starlink customers today. So in just over 5 years, we've added dedicated services for aviation, maritime, RVs and rail, and have expanded our emergency response capabilities. We've activated high-quality internet for millions of people, including those that live in some of the most remote places on Earth. Starlink is enabling rural school districts, counties, and tribal governments to offer online access to education, telemedicine, and many other critical services, in some cases for the first time ever. And yet, a third of the planet continues to go without access to reliable high-speed internet, so there's a lot more work for us to do. But Starlink was designed from the very beginning to meet these needs. And as each new version of Starlink comes online, the constellation's capacity and performance increases significantly. The larger V3 satellites that will deploy from Starship will bring gigabit connectivity to users and are designed to add 60 terabits per second of downlink capacity to the Starlink network. That's more than 20 times the capacity added with every V2 mini launch on the Falcon 9. And then on the cellular front, last month, SpaceX announced a deal that provides Starlink with exclusive spectrum for its next generation direct-to-cell satellites, which will be capable of providing broadband service to cell phones globally. Starlink is the largest 4G coverage provider on Earth. Over 7 million people across 5 continents already rely on Starlink to connect their LTE phones to data, voice, video, and messaging, where terrestrial service is unavailable. So we're excited to have the opportunity to help close those coverage gaps and ultimately eliminate mobile dead zones around the world. So yeah, there's a lot happening with Starlink, and there's a lot more to come. So let's head back to Amanda and Jake at Starbase to take us through today's flight profile.
Thank you so much, Tyler. So today's flight profile, we're looking to get our second re-entry with this iteration of ship. And prior to every launch, we work closely with the FAA and international air traffic organizations to efficiently and safely integrate launch and re-entry operations into the airspace.
And we've got a special guest here.
Today.
We're live.
What's up, guys?
How's it going? Good to see you, boss.
Hi.
Hey. How's the webcam?
Good. We're live right now.
What the?
Yeah. Getting ready for Flight 11. How are you feeling for it?
Good. This is the first time that I'm going to be actually outside standing and watching the rocket. Normally I'm in mission control and stuff.
Okay. Yeah.
But now I'll be standing out in the garden there.
Okay.
So
awesome.
It's really going to be much more visceral.
Yeah. Yeah. You're gonna feel
Great
it.
place
It's
to
gonna
watch.
be. It's gonna be. It's gonna be awesome.
When it's filming?
We'll be in here this time, but usually we're out there watching. Yeah.
All right. Sounds good.
Good luck
Later.
and have fun.
Have fun.
All right, so that was an exciting cameo there. But yeah, starting with liftoff, we'll get into the flight profile here. Super Heavy will ignite 33 engines, 24 of which are flight proven today. We'll power through ascent ahead of hot stage separation, where booster will shut down all but 3 engines. Stage 2 lights its Raptor engines while still attached to Super Heavy. That is what we call hot stage separation. We'll see a directional booster flip and engine relight for boost back. And we'll be intentionally headed to a splashdown in the Gulf with a V3 style landing burn demonstration today.
Meanwhile, ship will continue with its ascent burn to a suborbital trajectory, where it will attempt to deploy 8 Starlink simulator satellites. And we're also planning to relight a single Raptor engine. Then it's time for a re-entry, where we're once again testing the limits of Starship's heat shield by intentionally removing tiles. The ship will also perform a pretty dynamic banking maneuver that mimics the path of a return to launch site for Ketch that will fly on a future mission. And if all that goes as planned, we'll conclude the test with a landing flip, burn, and soft water splashdown in the Indian Ocean. So definitely another action-packed flight profile, Dan.
This is planned to be the final launch of this version of Starship, version number 2. Right now, we're actively building multiple next-generation V3 Starship and Super Heavy vehicles in the factory, kind of right behind us, so let's take a minute and nerd out a little bit. All right, those are going to be launching from Pad 2, which is nearing completion down here at Starbase. Both the pad and the vehicles are going to roll in really significant changes. This is building on everything we've learned from all of these flight tests to make a vehicle that we're looking to mass produce. Starting with the Starship upper stage, which is going to look pretty similar on the outside, but it's getting pretty much a complete overhaul under the hood. We're getting major design changes to its propulsion system that's going to accommodate that new version of Raptor, which puts out higher thrust. We're also getting an energy storage upgrades, tons of avionics changes, a lot of things that will enable longer duration missions. One notable thing you'll start seeing on the outside are these new docking adapters, which we'll use when we bring 2 starships together for propellant transfer. That's a core capability of Starship that we're going to demonstrate next year. Bottom line, though, this is the Starship we're planning to use for all of our next major milestones: orbital missions, return to launch site and catch, reuse, propellant transfer, and then making our way to the moon and Mars. Now, super heavy. We've shown some of this off, some of this hardware already coming out of the factory. It has upgrades like this, a redesigned fuel transfer tube. That thing's roughly the same size as the first stage of a Falcon 9 rocket. That channels all that cryogenic fuel down to Super Heavy's 33 engines. We made it bigger. It's basically a rocket inside of our rocket that gives us a faster, more reliable flip and simultaneous engine startup. New booster also going to have an integrated hot stage, a lot more vent area, and it's designed to be fully reusable. Offset just by the pressure in the fuel tank. That is the top of the fuel tank, and then we add a non-structural layer of steel on the top that helps take all the heating. It's mapped to where all the high heating goes. Grid fins also getting a big change, going from 4 down to 3. They're 50% larger though, much higher strength. They're also going to get used for vehicle lift and catch. That's all made possible. There's a new catch point addition on those grid fins. We've also kind of reclocked their position on the booster. That aligns them with the catch arms. Yeah, we got it right in the middle there. All right, and then powering it all, Raptor 3. Looks radically different, just straight up radical. Tons of major changes. It's coming in higher thrust, dramatic reduction in parts, tons of control mechanisms moved inside. Our McGregor team's built some additional stands like this one, which essentially is the bottom of a super heavy booster. Lets us do gimbal or steering tests, so that's been really exciting to see. We've also been getting vacuum versions of Raptor 3 into test. The first flight engines are already in production and are about to start acceptance testing for Flight 12. So a lot of exciting changes coming, and we're getting ready to mass produce everything, including one of the really key contributors to that rapid reusability, the heat shield tiles. Let's jump over to Tyler real quick in Hawthorne, who's got a really cool look at what's happening with tiles in Florida.
Thank you, Dan. Indeed, Starship's heat shield is the linchpin to full and rapid reusability. We can't launch, land, refuel, and launch again if we have to spend months refurbishing the heat shield after every launch, like they did in the Space Shuttle program. So, in a future where Starship is flying several times a day, many, many thousands of heat shield tiles will be required. So yeah, we need to get cooking on those tiles, which is exactly what's happening inside the fully automated bakery down at the Cape. In just 3 years, tile production at the bakery has surpassed the total number of tiles produced during the 30 years of the shuttle program. To go from the raw material to a finished tile, it takes about 40 hours. And today, the bakery is producing about 1,000 tiles a day. But it's set up to produce enough tiles for 10 ships per month, which is about 7,000 tiles a day, or a tile off the line every 13 seconds. So yeah, the bakery is well on its way to providing Starship with all the tiles for missions to Mars and beyond. And for today's flight, we've made a modification to the heat shield tiles. Dan, do you mind filling us in on what's being referred to as the Crunchwrap tile?
Absolutely. I always love to get to do a little show and tell. So we've got thousands of these heat shield tiles covering Starship. Now they're kind of all next to each other. There's a small gap in between all of them. You got to leave a little bit of space as that metal underneath will expand and contract. That way they don't crunch into each other and start breaking. However, that lets some of that plasma kind of seep through, and we see really high heating on the sides and then down on the metal. To help fix that, we have this, the crunch wrap that everyone has heard about. So we take essentially that's called Vulcan felt that we then wrap around. And so as these tiles are next to each other, you've got a small bit in between that's going to help offset that heating. It's just one of the ways we're continuing to iterate on this heat shield, getting towards rapid reusability. Hopefully it's going to help Starship live Moss. You know, everything is just going to get us to that end state of a fully and rapidly reusable vehicle. So pretty much the entire vehicle has those on it today. We've done this on multiple Starships previously, but this time pretty much the whole vehicle has it. So that was special for today. All right, enough heat shield tiles. Let's go quick check-in on the pad. So if you did notice, we did shift our T0 just a little bit. We're now counting down to 6:23 and 41 seconds Central Time. We shifted a little bit as we were working to finish clearing the range. We are monitoring sea and airspace, both here over the Gulf and in our splashdown location over on the Indian Ocean. We were working with the FAA, a lot of other international agencies to coordinate all of this. Good news, range is currently green. We're able to get everything out of the way that we are tracking in the Gulf. So weather status, all of our checkouts so far this morning, aligning our guidance, navigation, and control system, getting the vehicles ready for prop load, the farm, everything's gone pretty smoothly so far. We got through our go, no go for prop load. That happens at T-minus 1 hour and 15 minutes. We've been loading fuel and blocks on board the ship since about 53 minutes before launch. Booster started just about 10 minutes after that. We continue loading prop until just around 3 minutes before liftoff, and then at that point we'll be ready to go. So bottom line at the moment, we're looking real good. Again, 6:23 and 41 seconds Central Time is our target T0, so we're going to keep counting down.
Sounds like great news so far. Thank you, Dan. And we do say it repeatedly because it's important to understand, but these flight tests are all about the data. Data helps us build and fly faster until we're eventually ready to fly people and cargo at scale to Mars. That is our foundational mission and basically just the major inspiration for our work here every day.
Yeah, that's exactly right, Amanda. And our first missions to the Red Planet are just down the road, and we recently shared some exciting news. Starship cargo flights to the Martian surface for research, development, and exploratory missions begin in 2030, and we already have our first customer.
Yeah, exactly. Starship is open for business, and one of the first payloads will be provided by the Italian Space Agency. They recently signed a first-of-its-kind agreement to carry Italian experiments on the initial Starship missions that deliver customer payloads to Mars. In related news, Starship cargo flights to the surface of the Moon for research, development, and exploratory missions will start in 2028. So a ton of Starship activity to look forward to, and if you'd like to learn more about our mission to making humanity multiplanetary, go ahead and visit spacex.com/Mars. Okay, now as we get closer to launch, development continues down here at Starbase, Texas, to shape this growing city into a truly unique place to live and work. And part of being a city, particularly one surrounded by nature, is environmental stewardship. The nearby Boca Beach dunes have unfortunately been eroding at an alarming rate for some time, so SpaceX is teaming up with Cameron County and the city of Starbase to stop that erosion.
Exciting catch.
Residents and someone who's actually called Starbase home for over 3 years now, I can tell you the beach totally adds to the uniqueness and awesomeness of living here. Starbase is truly unlike any other place on Earth. You know, where else can you see the world's biggest rocket every single day?
Yeah, Starbase is definitely the place to be, and we're always looking for more people to come help build the future of spaceflight.
Yeah, particularly engineers, especially for our propulsion and mechanical system teams.
You could be working on tests just like these ones, proving out the designs of our next generation Super Heavy booster. Fun fact, we actually tested the booster to 13,400 tons of thrust, which is more than the power of 3.5 Saturn V rockets, which is just crazy. We're also looking for civil and structural engineers to help literally build the future.
Whether it's buildings like the Gigabays currently going up at both Starbase and the Cape, each is a massive vertical integration and assembly facility with over 700,000 square feet of workspace. Both sites are currently in progress, actually going vertical as we speak. Or you could be designing the Starship launch sites of the future. There's really no shortage of future to build here. So visit spacex.com/careers to see all of our openings if you're interested.
Okay, now as we head into terminal count, all eyes are on the rocket. Dan, how are we looking? Are we green?
Amanda, we are so green. Everything's still looking really good. So we've got a green range, not tracking any blockers there to launch. We're continuing to load prop on board the vehicle. We're just about to close out, so we'll close out again just about 3 minutes and 20 seconds before liftoff. We'll close out on ship, and then booster just about 30 seconds later. And then you end up with about 11 million pounds of liquid propellant on board those two stages. After we're fully loaded on the vehicle, the pad itself gets ready for launch. We do what's
Minus 40 seconds, a number of events will occur in rapid succession.